Hello, fellow students, and welcome to this lecture. Today we are going to talk about Hamilton paths, and we are going to see a demonstration about how to calculate this path according to Hamilton. So stick around and enjoy yourselves. And this is the problem that we have for today. We have the graph in the picture, and we need to define a Hamilton path according to Hamilton's demonstration. We need to insert the new vertices in the following order. And the first one is 1, 2, 3, 4, and 5. Okay, so the first thing that we see is that it is a directed graph, right? So let's see how Hamilton algorithm works. In the first step, we take the first vertex, right, which is 1. There is nothing else to do here since we only have one vertex yet. In the second path, in the second step, we take the second vertex, which is 2. And then what we need to check is, can we go from 2 to 1? Yeah, I would say we can, because we have a direct link from 2 to 1, right? So we can place the vertex 2 before 1, right? Because we can go from 2 to 1. This was the first step, and now this is the second step when we add the second vertex 2. Now we are asked to add the third vertex 3. So the first thing to check is, can we go from 3 to 2? In this case, we can't. We can't because this link is on the other direction, right? So we can't go directly from 3 to 2. Okay, so we can't place 3 before 2. So we start with the second vertex, as we have in the previous line, and then we need to check, can we go from 2 to 3? Yes, we can go from 2 to 3, right, following this link. And can we go from 3 to 1? Yeah, again, we can go from 3 to 1, right, following this link. So we can add 3 between 2 and 1. Right, it's simple. It's very simple. Now, in the next step, we need to add the vertex 4, right? And in this case, let's write it down. Let's write it down, okay? You have the written version of what we are doing. Okay, so the first step is we check if we can insert it before 2, right? Before the first node. There should be an edge from 4 to 2, right? So in this case, there isn't an edge going from 4 to 2. No. So we write 2, right? So we start by the vertex 2. Second step, well, this could be like inserted as the first node, right? As B0. According to the algorithm. Then we check if we can insert it as B1, right? And this is between 2 and 3. For this, there should be an edge from 2 to 4 and another from 4 to 3, right? And in this case, we have an edge from 2 to 4, right? But we don't have any edge from 4 to 3. So we cannot insert it here, right, as B1. So we go to the next position and we check if we can insert it as B2, which is between 3 and 1, right? So there should be an edge from 3 to 4 and from 4 to 1. So let's check it. From 3 to 4, okay, there is an edge here, there is a link here, and from 4 to 1. So yes, right? So yes, we can insert it as B2 between 3 and 1. So we go to the next step and we insert 4 as B2 between 3 and 1. Okay. Finally, 5. For 5, we check if we can insert it as V0 before 2. So is there any path from 5 to 2? Yes, there is a path, right? So we insert 5 here as B0. And finally, we have defined a Hamilton path inserting the vertices in the order given, in the given order, right? Let's see this path, which is 5, 2, 3, 4, 1, right? So that's correct. Remember that the Hamilton path is a path that visits each vertex, right? Each vertex on the graph, and only once, right? So if in this problem you had more or less than 5 vertices, you wouldn't be able, right, to define a Hamilton path with all that vertices. You need exactly 5 vertices to define the Hamilton path. Let's see another example here. In this case, we start with the vertex number 5. Then we are asked to insert 4. We check if we can go from 4 to 5, and we can't. We can't go directly from 4 to 5. So let's see if we can place it after 5, right? Can we go from 5 to 4? Yes, right. So we place it after 5, right? So the first step, we had only 5, and now we have the path from 5 to 4. Now we get the vertex number 3, and we check if we can place it before 5, right? Can we go directly from 3 to 5? And no, we can't go directly, right? Let's see if we can place it in the position V1 between 5 and 4. Can we go from 5 to 3? Yes, we can. And can we go from 3 to 4? Yes, we also can. So we can place it here as B1 between 5 and 4. Okay, the next one is 2. Let's see if we can place it as V0. And the answer is no, because we can't go from 2 to 5. Let's see, between 5 and 3. We can go from 5 to 2. And we can go from 2 to 3, right? So we can place it as B1 between 5 and 3. And finally, we have the vertex 1. And let's see where we can place it, right? Can we place it before 5 as B0? Can we go from 1 to 5 directly? Yes, because we have an edge from 1 to 5, right? So we can place it in the first position. 1, 5, 2, 3, 4. So as you see, we have Hamilton path 1, 5, 2, 3, 4 that visits every vertex on the graph exactly once. And as you can see, this path is different from the first one, right? Because we are adding the vertices in a different order according to the algorithm. So that's all for this demonstration. I will stop sharing the screen now. So that was the problem for today regarding Hamilton paths and how to create them according to Hamilton's algorithm. As always, if you have any question, please don't hesitate to ask down in the comment section. And if you noticed any mistake, in my lecture, please also let me know to try to correct it also in the comments. That's all for today. Thank you for joining me, and I will see you in the next video. Ciao, ciao.